Hello everyone. In this video we're going to simplify this radical expression with an index of 3 by rationalizing its denominator. So we'll go ahead and break it up into two radicals using the quotient rule for radicals. Notice that the negative is outside the radical. It's just going to carry at each stage. So make sure you just write it to begin with so you don't forget it. So we get the cube root of 5p over the cube root of r to the 8. So rationalizing a denominator means having no radicals in there. So if we take a close look at r to the 8, we realize that's not a perfect cube. So we want to know what is the smallest expression that we can go ahead and multiply it by to turn r to the 8 into a perfect cube. Of course, you don't have to use the smallest expression. It's just that the smallest expression will be the most efficient way to go. That's all. Otherwise, any expression in this radicand position, which would turn r to the 8 into a perfect cube, would work. But why would we want to go with more than we need, correct? So there's a difference between efficiency and necessity. It's important to understand. All right, so if we take a look at r to the 8, we can see that it's basically 8 factors of r. So this is the simplest expression of r to the 8. Yeah, it's rather long, but it shows you the details of its existence. Notice we have 3, 6, 8 factors. So we notice there's a perfect cube right there. There's a perfect cube right there. And there's almost the perfect cube, right? So what's missing, as you can see, what's missing is a single factor of r to turn r to the 8 into an r cube, because if we had that single factor of r, then this whole thing would have become r to the 9, which, as we know, is a perfect cube. And it's a perfect cube of what? What do you cube to get? What expression do you cube to get r to the 9? Clearly r cubed. And that's because of the power rule, which goes like that. Okay, so we can see that all we need to multiply inside this radicand is going to be just a single factor of r. And of course, whatever we multiply the denominator of a fraction by, we'll have to multiply the numerator by as well. So doing that will give us, don't forget the negative to begin with, the cube root of 5pr on the top, and down below we get the cube root of r to the 9. So we get negative cube root of 5pr over, now we know what the cube root of r to the 9 is. It's the number we have to cube to get r to the 9, and as we saw down here, that's going to be r cubed. Now, the easiest way to get that, of course, is to divide 9 by 3. Remember, we had this nice rule, the nth root of x to the m equals x to the m over n. So we can use that rule to get this, or we can just reason it out. Now, of course, we wrote this out here for maximum understanding. However, obviously this is not efficient. What if instead of r to the 8, we had r to the 80? Would we want to sit here and write 80 factors of r? Of course not. So if you notice, what you need to do is you need to ask yourself, what is the closest number to 8, meaning what is the smallest number greater than or equal to 8, which is a multiple of 3, and we can know that that's 9, and therefore all we have to do is from to go from r to the 8 to that perfect cube expression is to multiply by r. That's the reasoning that you want to use, so that you don't have to do this every time. It's one thing to see something during an instructional video. It's another thing to have to do it over and over every time you see a problem. So that's basically how you approach these, and I hope that helps. So be safe until the next meeting.